Good morning, guys. Today we're going to be looking at Notes 409, solving logarithmic equations. Let's just start with the intro. Equations with logarithms that have variables are called logarithmic equations. We can solve logarithmic equations by using the property of equality for logarithmic equations. And so the property is listed here in this box. It basically says if I have two logs equal to each other and they have the same base, then you can say that the contents of those logs are also equal to each other. So in this case, if I have log of something equals log of something else, then those two are equal to each other. In this case, x and y are equal. So an example of this is shown here, and actually this b should be an 8. They both should have an 8. So this should be an 8 here, 8. Okay. So let's look at this again. So we have log base 8 of x minus 2 equals log base 8 of 5. If I have two logs equal to each other and they have the same base, then I can say that x minus 2 equals 5. And then I can solve using Algebra 1 methods. Okay. Next, we have a set of rules for today. Let me zoom out a little bit more. Okay. So the rules are the following. First, we want to get the logarithm on one side, or make sure that it's by itself on one side. Then we're going to apply the property that I just talked about. Then we're going to solve using algebra methods. And then step 4 is checking for extraneous solutions. An extraneous solution is a solution that will make the equation false. And so what we're going to be looking out for is anything where we have a negative inside of a log or a 0 inside of a log. Because we talked about these last class, that these are undefined situations, and so these cause solutions to be extraneous. All right, so let's look at examples. First example, solve the following logarithmic equations, check for extraneous solutions, show all your work. Okay, so here basically we want to see, do we have a log by itself? And we actually have a log by itself on the left side and a log by itself on the right side. And so if I have two logs equal to each other and they have the same base, in this case the base is 2, then what can I say about the contents of the log, right? What can I say about 2x minus 1 and 5? I can say that they must be equal to each other. So 2x minus 1 equals 5. I can solve for x, right? Add 1 on both sides. Let me change the color here. These are going to cancel. Then I get 2x equals 6. Divide both sides by 2. X equals 3. Right. So, but before I box my answer, I'm going to check my solution. So we check our solution by taking the equation that has the x in it and copying it over here. So I'm going to copy it over here on the left side. I have log base 2, and I have erase this, 2x minus 1, but I'm going to replace it with the answer that we got for x, 2 times 3 minus 1 2 times 3 minus 1 is 5. Did we end up with a positive answer? Yes. So I can put a check mark. And then I can box this answer. Alright, let's go to the next example. I'm going to zoom in a little bit over here. Okay, in this case we have two ln's equal to each other. And so we would say, ln has a base of e. So if I have two natural logarithms with the same base, then what can I say about the contents of these two? Right? Then 3x must be equal to negative 2 plus 2x. I can solve for x by subtracting 2x, subtracting 2x. 3x minus 2x is x. Bring down the negative 2, and these cancel. But then I gotta check my answer. So I'm gonna rewrite the ln of 3x. ln of 3x. Substitute x. We got negative 2. What's 3 times negative 2? That's negative 6. Did we get a positive answer or a negative answer? We got a negative answer. So that means that this answer that we got is an extraneous solution. Because we don't want to have a negative inside of a log, because that causes the log to be undefined or the value to be undefined, and so that means we have a false statement, and so our solution is extraneous. Example 3 now. I have a log that doesn't have a base, so then it's assumed to be a base of 10. Base of 10. If I have two logs equal to each other with the same base, then I can say that the contents of the log are equal to each other. And then we can solve for x. Again, subtract x, subtract x. These cancel, leaving me with 6 equals x plus 7. Then I have minus 7, minus 7. 6 minus 7 is negative 1. X equals negative 1. Then I gotta check my answer. So what's log of negative 1 plus 6? That's log of 5. Did I end up with a positive answer or negative, right? I ended up with a positive inside of the log. So that checks off. So x equals negative 1 is my answer. All right, now let's look at the next two examples. These actually have a different set of instructions. It says if I'm solving an equation with a log on one side, I need to make sure first of all that the log is by itself, it's isolated. If it needs to be, or if it's not isolated, make sure it's isolated. Then we want to rewrite the logarithm into an exponential. Okay, so if you remember when we would change a logarithm, we would have something like base a equals x, something like this. This was our logarithm equation. And then when we wanted to change it into, you can go back and forth, but we would change it into an exponential. We would write it the following way. We would say b to the power of x equals a. So this is what step 2 is talking about. When we have a logarithm, we can convert it into an exponential. Then once we convert it, we can solve and then check for extraneous. So let's look at example 4. It says, solve the following logarithmic equations, check for extraneous solutions. So is the log by itself? So if you notice, if I circle the log term, it's this term that I circled, and it's not by itself, right? It has a -7 in front. The -7 is multiplying, so it's the opposite of multiplication, division. So I'm going to divide both sides by -7. That the 7s are going to cancel on the left. That's going to leave me with log base 2 of 4x equals, what's negative divided by negative? Positive. And 21 divided by 7 is 3. So now we can convert this into a logarithm, right? If I have an exponent, I have log base 2, I have 4x, and I have 3. So I can rewrite it as 2 to the power of 3 equals 4x. 2 to the power of 3 equals 4x. What's 2 to the power of 3? What's 2 times 2 times 2? It's 8. Then we can divide both sides by 4. And x equals 2. We can check our answer. Log base 2 of 4 times 2. So I'm just copying this equation on the right and substituting x with 2. So that gives me log base 2 of 4 times 2, that's 8. So I get a positive 8. So x equals 2 is my answer. Right. Now let's look at the last example, example 5. If I circle the logarithm term, it's this term right here. I want to get it by itself, so the opposite of adding 6 is subtracting 6. It's going to leave me with log base 4 of x equals -1. I can rewrite this as an exponential, right? 4 to the power of -1 equals x. But remember, if I have a negative exponent, I can take this term and move it to the bottom of the fraction. So I'm going to end up with 1 over 4 equals x. Then I'm just going to plug it into this equation, right? So I have log base 4 of x, but I'm going to replace x with the answer that I got, 1/4. Is that a positive answer? Right, 1/4 is positive. So positive is okay inside of a log. So then 1/4 is my answer. Awesome. So that brings us to the end of the lesson for today. And so I hope this helps you with the assignment. And I'm going to go over it next class to see if you guys had any questions. But good luck on the assignment, and I'll see you guys the next time I see you. So that'll be on Tuesday maybe.